Hello friends, welcome to first video of Astro Interest. In this video I'm going to show you a simulation of a software named as Celestia. It's a wonderful software. So I have always used that in Windows. So let me first install this in Ubuntu. Then I will show you how fascinating it is. So we'll go to Ubuntu Software Center and search for Celestia. Okay, let's install it. I have always used this in Windows and it works very nice. So now this Celestia is installed. So yeah, it is here. So we can go to this. Let's check how it is. Yes, it's the same as in the window. So yes, so here we have many types of motions. So we can zoom out, we can rotate in 3D, we can also rotate in 2D. Here the position of the observer is fixed, but the whole sky can be rotated. If you want to search something, you can directly start typing. Okay, wait. Yes, you can first enter, then so for example, if you want to search sun, yeah, it is now located at the sun. It shows that it has selected the sun. You can press G for go, so it will directly go to the selected object. So here it is sun, so you can view from all three directions. You can go closer. If you want to see planets, you can just go here and go to orbiting bodies. For example, in planets you can select Mercury. So the Mercury is selected. You can just press G, so it will go to Mercury. So you can zoom a bit out. So you can see this is the bright phase where the sunlights are falling, and this is the dark phase where there is night. So isn't it look like a moon a bit? So those of you who are still wondering how moon changes its shape in the night, so you can see it's like full moon, and then slowly the bright portion becomes smaller and completely fades away. So you can see the sun's lights are falling directly on this part. That's why this part is brighter. So anyway, what we can do, where is the sun? Yeah, this is sun. We can select. Okay, so let me first change. Okay, we'll go to sun. So we can go to other bodies, for example planets. Let's go to Venus, press G. So here you can see it's so smooth that not much texture are visible because it's covered with thick clouds of carbon dioxide and sulfur, etc. So you can also see its faces. This is the bright side where sunlight is falling, this is the dark side. You can see there is no moon of it. Let's go to other planet. We have already seen Earth, or let's see if I go. So yes, you can see. So this is the bright side, which is showing daytime. This is, I guess, is North Pole. Yes, this is North Pole. This is North America, which is appearing very bright. This is South America, and you can see other places also, like this is Africa, and this is Europe. This is Asia. So if we zoom out, we will be able to see moon. So yeah, it is here, it is moon, this thing, which was, you can see while zooming out it is moving, so we can guess it is a closer object. So we can just go to it. When we press go, it selects the center at that object. Textures are not clearly visible, I don't know, there might be some plugins missing. So you can see bright side and dark side. Now we can go to other planets also. So the most fascinating one, the Saturn, for example. Let's go. Yes. So while zooming out, zooming in, you can see how many dots are moving along with the Saturn. So these dots are clearly showing that these are along with Saturn. Actually, these are the moons of Saturn. For example, this one, Enceladus. You can see many moons. You can go to any one of them. Just press G, select that and press G. So it is Pan, the moon of Saturn, with distance of our camera or our observer from this surface is 70 kilometer. Radius is 17 kilometer, and you can see the ring of Saturn. Now let's zoom out and see how small it is. You can also see the shadow of the rings on the Saturn, which is appearing so beautiful. And you are seeing this in real time. You can see this 4th April. Here it is 10:41 AM in the India. There are many other things also. For example, like time, you can change the speed of time. Okay, this was time forward and backward. Time rate. Okay, now time is forward, so we can increase the time rate by 4. 8, 16. As you increase the time rate, the object will start moving. So first let's focus it on this Saturn so that we can see the spin. So let's increase the time more to time rate 256. So now you can see the moons are moving around the Saturn. Okay, let's increase more. Now you can easily see. So this is really cool to see how the objects rotate. As we have increased the time, you can see that our time is also increasing very faster. So let's stick to our original time. Okay, so we can go to other objects, for example like something Halley's Comet. Let's see where it is. So it's 30-kilometer comet with a radius of we are from our camera is away from this object by 30 kilometer, and the radius of this object is 7 kilometer. So we can see there are no rings apparently, because we are very away from the Saturn, from sun. So let's see where is sun. So you can always press H to see where the sun is. Sun is 34 AU away from this distance. So you can see we are very far away from the solar system. So what we can do is we can focus on this object and increase the time speed, so that okay, let's do this. Okay, time rate. I think this object is started rotating because we have increased time. Yes, but the distance from sun is not changing much. Okay, so now we have increased time by too much. No, this is the last thing I will be showing this video. Next time I will show a lot of more things. I'm using this software after a very long time. So let's see how tail develops around it. So currently the distance is increasing. So you can see we are moving away from sun. It is still increasing. Now it is decreasing. Oh, we missed it. Sorry. So you seen that the tail was developed, but the time was so fast that we missed it. So this time we will slow the time when the tail will start developing. So it is decreasing. So let's see. Where is the object? Okay, this is the object. So we are at 25 AU astronomical unit, which is the distance between Earth and Sun. 22. Still nothing is much visible. Yes, you can now see the tail has developed. So you can see this tail has started developing. We are at 6 astronomical unit away from the sun. So we can increase the distance time a little bit. As we will be going towards the sun, tail will be getting longer and longer. Currently it is just visible, so let's increase time speed more. So now you can see that tail is becoming brighter and brighter. So now, yes, of course you can see it. Yes, we are at 4 astronomical unit. Okay, it is getting out of our screen, so let's, yes, so let's first show you how our comet is looking from inside. It is the same object, small, around which this white colored gaseous tail is developed. Okay, where is sun? Press H. So we are at 3 astronomical unit away from the sun. I don't know where is sun. They should be somewhere here. Yeah, it is here. So we can go to our comet back. Okay, let's rotate a little bit. Okay, so let's increase the time speed. We are at 3 astronomical unit, means the 3 times the distance between Earth and Sun. It will be somewhere between Mars and around Mars. So it's okay, this event will be so fast, so we have to slow down a bit. You can see the sun is in front and the tail has developed by a large amount, very large as compared to the size of this object. So let's, you can see that the tail is rotating because the comet is approaching the nearest distance to the sun, at which the tail will flip its position, so it will be on the front side of the object. Till now it was on the back side of the motion, means in the direction away from the motion. So now you can see that it is rotating because the object, the sun will be on this side. So now we are at 1.30 astronomical unit. Oh, tail is getting longer. So brighter, very bright. We can look very closely. It's very bright. This is one of the most fascinating thing I have seen in this software. That's why I really love this software. So you can see this object. Yes, of course, this is a really nice look. You can see all 3 or 4 planets and the comet. Look at the size of the tail. This is the distance between these planets, and now the distance is increasing again, so comet is going away from the sun. This is Mars, red one. This is, I don't know, most probably Venus. So you can see it is going away from the sun with 2.7 astronomical unit. So if we zoom out, yes, we can see all 4 planets, this, and this. And this is our comet. Yes, of course, this is our comet. So now it is going away from in this direction. So somewhere we can also have what happened? What? Okay, now we do that. Anyway, okay, what happened? Let's see some with the sun. let's go to Halley Comet. Okay. Something fishy had happened. I pressed Y and it synchronized the orbit. Okay, so I hope you enjoyed this part of how the tail developed in the Halley Comet. So next time I will be showing you lot more things. So thanks for this. Thanks for watching.